Hi, in this video, we will learn how to calculate the noise dose based on the ISO and OSHA standard. The aim of the noise regulation is to protect not only the workers but also the employers. Through observing the permissible noise exposure limit, we can protect the workers from the excessive noise in his working environment. In some sectors, such as the oil and gas sector, the worker is required to join some good hearing conservation programs that keeps on monitor the workers' hearing. If the employers can follow the noise regulation, this will protect them from the hearing loss compensation claim. The noise regulations are not uniform throughout the world, but two generally used standards are the ISO and the OSHA regulation. The previous allowable LAEQ is important when the type of noise is an steady noise, as you see in this picture, where the dBA amplitude remains fairly constant with respect to the time. However, for other types of noise, such as the time-varying noise or the fluctuating noise as shown in this figure, or the impulsive noise as shown in this. So for these two cases, the allowable noise exposure are quantified by different parameters such as the dosage limit and also the maximum peak impulse level. Based on the noise type, we can decide what kind of noise exposure parameters that we can use. For the steady noise, the safe continuous limit, which is the LAEQ, is equal to 90 dBA based on 8 hours per day basis. So this is for the OSHA standard. For the ISO standard, the maximum LAEQ is equal to 90 dBA based on 40 hours week basis. So if we take the average per day is equal to 8 hours. So in these two cases, we can simplify the LAEQ must be less or equal to 90 dBA for 8 hours per day. The maximum steady level must be less than 115 dBA for both of the standard. If the noise type is fluctuating noise or what we call the time varying noise, in this case we are using the dosage limit for the noise exposure parameter. For the OSHA standard, the dose computation is based on the OSHA permissible exposure time. For example, OSHA allows continuous exposure of 90 dBA on 8 hours per day basis. On the other hand, for the ISO standard, the dose computation is based on the ISO permissible dose limit. For example, ISO allows a 100% dosage at 90 dBA based on 8 hours per day basis. In overall, the dosage limit must be less than 100% for both of the standards. For the impulsive noise, we can use the maximum peak impulse level as the noise exposure parameter. So for the OSHA standard, we use the maximum 140 dBA for 100 impulse per day. For the ISO standard, it treats the impulsive noise as the equivalent noise level measured on the slow scale, but with a constant 10 dBA added to the level, and dosage work out accordingly. So you will learn more about what is the slow scale in the measurement chapter. In this study, we will focus to investigate the steady and also the fluctuating noise by using the LAEQ and also the dosage limit. Therefore, this is for your extra information. In this table, you can see for various sound pressure level in dBA, the OSHA exposure time as well as the ISO dosage in percentage per 8 hours per day are provided in this table. So you can see for 90 dBA for the sound pressure level, we only allow to expose to it for 8 hours and 0 minutes. So this is for the OSHA standard. And for the ISO standard, for the same 90 dBA sound pressure level, If a guy stay at this working environment for 8 hours per day, then the ISO dosage will be equal to 100%. From the table, we can see that if we increase from 90 dBA to 95 dBA, the maximum exposure time will reduce from 8 hours to 4 hours, which means for every 5 dBA increment, the hour will be reduced by half. So this is for the OSHA standard, and we can use this relationship to find the information that is not provided here. So you have 85 dBA, which is equal to 16 hours for the OSHA exposure time. We can use this information to find the OSHA exposure time at 80 dBA. So now in this case, you can see that we minus 5 dBA. By using this relationship, we know we should multiply 2 to 16 to obtain 32 hours. So this is the exposure time at 80 dBA. To find the exposure time at 81 dBA, then you can refer to the 86 dBA, where every reduction of 5 dBA, the exposure time will increase by 2 times. So 13 hours and 56 minutes. If you multiply with 2, then you obtain the OSHA exposure time to be 26 hours. That's with the 112 minutes. So we can simplify this into 27 hours and 52 minutes. By using similar approach, we can find the exposure time at 82 dBA equal to 12 hours 8 minutes multiplied with 2. Then you should obtain this answer. Then you continue with the 83 dBA by taking 10 hours 34 minutes and multiply it with 2. Then you should obtain the answer here. Lastly, 84 dBA, you should obtain the OSHA exposure time equal to 9 hours 11 minutes multiplied with 2. So it gives you the answer here. On the other hand, for the ISO standard, for every 3 dB increment, the dosage will increase by 100%. For example, at 90 dBA is equal to 100% of the dosage. If we increase the dBA by 3 to be 93 dBA, so in this case you can see the dosage increase by 100%. By rule of thumb, we should only stay maximum at 90 dBA for 8 hours per day. So in this case, you stay for 93 dBA for 8 hours per day. Therefore, you will suffer the overdose. So you have 200%, where it is 2 times larger compared to the 90 dBA case. So you can see for every 3 dBA increment from 93 to 96, 96 to 99, 99 to 102. So you can see the dosage is increased to 400, where you see is multiplied with 2. So you multiply 2 again to obtain 800. Multiply 2 again to obtain 1600. So we can use this relationship to find the unknown here. So this is the dosage at 81. So you can refer to the dosage at 84 here. So in this case, if you reduce by 3 dB, so we should divide the dosage by 2. So in this case, you obtain 12.5%. So this is how we read the table. At 110 dBA, the allowable exposure time is only 30 minutes based on this information. So based on the OSHA standard, we should stay maximum 30 minutes for this working environment. For the ISO standard, if you work at this working environment, which is the 110 dBA, for 8 hours continuously, then it will cause the overdose. So overdose means exceed 100%. So in this case, it's exceed a lot. So this is the maximum allowable time that we allow to stay in an environment with 110 dBA. So if we stay longer, which is greater than 30 minutes, and it will cause overdose. So you can see that if we stay longer up to 8 hours per day, then it will cause the overdose. On the other hand, if we stay lesser compared to the maximum allowable time here, then the percent of the dosage will be reduced lesser than 100%. From the table, you can see the highest dBA is equal to 115. So this is the maximum level of working environment. So exceeding this value, you have the potential to get hearing damage instantaneously. So please make sure the working environment should be always less than 115 dBA. So we can actually use the dosimeter or the noise dosimeter here to measure the noise exposure of the employees during their normal working day. So you can see in this case, the employees put the meter inside the pocket and measure the noise that we receive near to our ear. We know that a worker should receive less than 100% of the noise dose per day. The dosimeter will measure the noise level as well as the length of the time that the employee is exposed to the noise. From time to time, it can measure the accumulated noise dose by this worker. When the noise dose is approaching the maximum 100% level, so in this case, it will send the alert to the worker to stop working. Besides the percentage dose, the dosimeter can also measure the sound level, time average sound level in LEQ or the LAEQ, peak sound exposure level SEL. In this example, let's try to calculate the noise dose based on the ISO standard. So from the table, you can see a worker spends 8 hours per day at 4 different working stations from A station to D station. The time that the worker spent at each station are given in minutes here. The noise level for each station are given in dBA unit. If these two information are provided, how can we find the noise dose of the worker after he works for these 4 stations? In the first step, let's find the ISO dose for the corresponding level mentioned here. The ISO dosage can be found from this table. So for the 98 dBA is equal to 630%. For 83 dBA is equal to 20%. For 103 dBA is equal to 2000%. And for the 85 dBA is equal to 30%. By referring to the previous table, you should obtain the ISO dosage to be this value, corresponding to the dBA value here. Bear in your mind the ISO dosage here is in percentage for 8 hours per day. For example, if you work 8 hours per day in station A, which has 98 noise level, then you will receive 630% of the noise dosage. However, you only work 24 minutes in the station A. So what is the corresponding noise dose? We can convert the 24 minutes easily to the hours, so you should obtain 0.4 hours. So 8 hours, you obtain 630% of the noise dose, and 0.4 hours give you how much noise dose. So we can take the 0.4 divided by 8 and multiply it with the 630 in order to obtain the noise dose at station A. After perform the calculation, you should obtain the noise dose at station 1 equal to 31.5%. Therefore, you can substitute it inside the table here. For the station B, at 83 dBA, for 8 hours, it will be equal to 20% of the noise dose. You stay 336 minutes, and if you divide it with 60, you obtain the answer in hour. So take the 336 divided by 60, you should obtain 5.6 hours. So 8 hours give you 20, 5.6 hours give you how much? To compute this, you can take the 5.6 divide with 8 and multiply with 20. This gives you the noise dose at the station B. So after you perform the calculation, you should obtain the answer equal to 14. So let's substitute this inside. So if we compare to the answer, we get it correctly. By repeating the same procedure, we can find the noise dose and station C and station D. For the station C, let's take the 10 minutes and we need to convert it to the same unit, which is in hour. So 10 divided by 60, we obtain the unit in hour. And we divide it with 8 hours and multiply it with 2000. Then you should obtain 40%. For station D, so we convert 110 into the hours by divide it with 60, and then we take the 110 divided with 60 and divide with 8 hours and multiply with 30. So by doing that, you should obtain 7% of the noise dose. There is some correction here. This should read 41.7% and this should read 6.875%. So the noise dose at each station is called the partial dose. To find the total dose for the walker, we need to take the summation of all the partial dose here. So when you take the summation of all the partial dose, where 31.5 plus 14 plus 41.7 plus the 6.875, then you should obtain the final answer here to be 94.075%. Based on this result, we can compare to the standard where it says the allowable percentage of the noise dose should not exceed 100%. Since this value is less than the allowable value, therefore the walker is just alright. Besides that, if you use these two formulas to compute the partial dose and the total dose, you will obtain the same result. For example, at station A, the percent of time that you spend per 8 hours is equal to 24 minutes divided by 8 hours. So when you take the 24 minutes and divide it with 8 hours, so you need to be careful. The 8 hours should be converted to minute by multiply with 60. So after you compute this and multiply with 100%, then you should obtain the percentage of time at station 1 here. So which is equal to 5%. Then you continue to perform the calculation for the partial dose by taking the 5% divide with 100 and multiply with the corresponding ISO dose. Then you obtain 31.5, which is exactly the same like we calculated previously. Let's solve the same problem, but this time we use the OSHA standard. Similarly, based on the level dBA here, the OSHA exposure time for 103 dBA is equal to 1 hour and 19 minutes. For 98 is 2 hours and 50 minutes. For 85 dBA is 16 hours. For 83 is not given. Therefore, we can use this relationship to obtain it. So we need to refer to 88 dBA, which is equal to 10 hours and 34 minutes, and we multiply 2 in order to obtain the OSHA exposure time here. which is equal to 20 hours and 68 minutes. So the 68 minutes here is equal to 1 hour and 8 minutes. Therefore, you obtain 21 hours and 8 minutes. Therefore, you can substitute the OSHA permissible exposure time into here. By taking the time spent at the station A and divide with the OSHA permissible time and multiply it with 100%. Then, by doing that, you can obtain the partial dose at station A, which is equal to 24 minutes divided with 2 hours and 50 minutes. If you convert to minute, you should obtain 170. And after you multiply with 100%, you should obtain 14.12% of the partial dose. By using the same procedure, that is, take the time spent at the respective station B, C, and D here, and divide with the corresponding permissible time here, and multiply it with 100%. Then you should obtain the partial dose at BCD station here. So after you compute all the partial dose at all the 4 stations here, take the summation of all of these, you should obtain the total dose equal to this answer. So if we compare to the allowable 100% dose, so this is much less than the allowable limit. Therefore, the worker is alright. So when we compare the OSHA standard and the ISO standard, you see for the same environment, the total dose that is computed by the ISO standard is much higher and closer to the allowable limit. Therefore, we can say the ISO standard is more strict compared to the OSHA standard. So far, you have learned how to calculate the LAEQ as well as the noise dose. These two types of measurement are very important for various types of noise here.